Hey everyone, so today I have a Leetcode problem for you. It's problem 114, flatten a binary tree to a linked list. So you're given a binary tree and you're supposed to flatten it to a linked list. But the thing is, it has to be in place, which means we can't use another data structure to keep track of everything, make a new list, and then just return that new list instead of modifying the list we have. So we're given a tree like this, and we're supposed to make it look like this. So nothing should have a left. Every node's left should be null, and every node's right should be filled except for the last node. Um, so we're supposed to kind of transform it into a pre-order. We're looking at the pre-order, and that's the order in which we'll transform it. So if you don't remember the pre-order, it's root, left, right. So first would be the root, then you call pre-order on the left, so you call pre-order on this, so you do the root, then you call pre-order on this, but it doesn't have a left, so you just do the root, then you take the right of this one, and so on and so forth. So this really isn't a great example. It doesn't really have all the sort of possibilities you have to think about. Um, every node here, it either has both nodes full, both nodes empty, or in 5's case, the right full and the left empty. But there's no sort of situation in which you have the left full and the right empty, which could be a possibility in your tree. So what I've done is I've created a kind of more complete tree. And as you'll see, you've got the 1, it has a left and a right. You've got the 3, it has neither a left nor a right. You've got the 4, it has a left, no right. The 7, it has a right, no left. The 9, it has a right, no left. And the 10, it has a left and no right. And this is kind of the output it would look like. I use numbers just like the example in Leetcode to make it easier, but the numbers should end up being in order. So a good way to think about this is kind of a recursive divide and conquer solution. So we have the 1, we know the 1's gonna kind of stay here, but if we can sort kind of flatten everything from the 2 and lower, put it in the right, put it right here so that this would be a 2 instead of a 6, and then we flatten all of this, we flatten all of this stuff, and then we put it after the 5, it would be a flattened tree. So as you can see, it's kind of a recursive solution. So what we're going to want to do is we're going to want to, first, we're going to need to flatten the left side. So we can flatten the left side. Then we're going to have to flatten the right side. And then what we want to do is we're actually going to need to keep track of the last element in the left side. So we're going to need to find some sort of way to keep track of this 5. So then we can say 5 dot right will equal the first element in our root dot right. So I'm going to write keep track of last element on left. I'll just move this over a little bit so you can still see it. Move it over a little so you can still see it. And then we can set the last element. We can set last element on left dot next equal to root dot right. So last element on left dot next equals root dot right. So you would say like 5 dot left dot. We would say like 5 dot right equals root dot right, so 5 dot right equals 6, and then we can set root dot right equal to 2. So our root dot right would be equal to our root dot left. Scroll down a little. So these are the main things we have to keep track of. First, we actually might want to flatten the right side first, just so it's flattened. Then we can flatten the left side, because when we flatten the left side, we need to keep track of it. And then we can say like our last element in our left dot next equals our flattened side dot right. It doesn't really matter, but that's just a good way to do it. So if our left and right, oops, this should say both. Oops, excuse me. Sorry about that. This should say both. As you can see, it's kind of hard to draw, but both null. Sorry. Gets the job done. So our both null is kind of our next, I would say like easier option. Oops. Oh my goodness, sorry. Okay. So our both null is kind of our next easy option. So say we're at like the element 3 or like the element 5. If we're both null, we don't really have to flatten the left because there's no left. We don't want to have to flatten the right. There is no right. But in some situations, our last element might be what we need. So our last element could potentially be this 5. So our like, for example, when we call flatten left from the root, we're saying flatten 2. Well, it's kind of the same situation. So we're going to flatten the left, then flatten the right, and then I'll say our left dot next, so our 3 dot next equals our root dot next, our current root, which is 2 dot next, or 2 dot right, and then we'll put root dot right equals left, and then set our left to null. So it's kind of a recursive situation, but if they're both null, we just want to make sure we're returning our value. It might become a little more clear later on, so return value. So if our left is null, so for example, this 8, if this 8 is, or, excuse me, if we're looking at the 7, the left is null, the right is not null. So what we want to do in a situation like that, where our left is null and our right is not null, is we basically just need to flatten the right, and that's it. And then we might want to return whatever comes out of that kind of fruition. Return. And then our kind of last case, if our right is null but our left is not null, so like this 4, we're going to want to flatten the left side and then move it over to the right side and then set our left side equal to null. So flatten left, set root dot right equals left. Sorry, I didn't make this big enough. And then set our left equals to null. And one thing I forgot to mention is when our left and both right side are neither null, we also want to set our left side equal to null when we're done. Because in our example, you'll see all the lefts are null. So this is about it. I will show you how to solve it on the Leetcode now. We can just kind of keep track of that. Okay, sorry I have 100 million tabs open. So I've already completed the solution, just to make sure it works. The first thing you want to check in your solution is if they give you a null root, you don't want to do anything. It's null, so you don't do anything. So you can just like return But if it's not root, if it's not null, then you want to flatten it. So I created a helper method called flatten return last. And what it does is, like I mentioned earlier, you need to return, you're going to need a return value. So like this is a void function, so it's not returning anything, but we made a function that will return a tree node. So for example, when we flatten the left side, we want to have this 5 value returned. So in this method, we're taking our first our root, and first thing we can check is if the left and right are both not null. So if root.left is not equal to null and the root.right is not equal to null, then we want to flatten. So we want to flatten our right side first, actually. We want to flatten our right side. And then we want to flatten our left side. And it should be root.right and root.left. So we flatten our right side, we flatten our left side, but we need to keep track of what our left side returns. So we'll create a tree node left return, and whoops, sorry about that. So flatten our right, flatten our left, we keep track of the last element our left would return. So hopefully we want to return this 5. And then we're going to want to set the 5's.right equal to the root.right, to our 1's.right. So our 5.right would equal 6. So our root.right equals left return. And then we can, so we have this 5 pointing to the 6. And now we just want the 1 to point to the we want this 2 to be on the right. So this 5 now, you can look at it. Now it already, whoops. So our 5 now has an arrow to our 6. And now we just want our 1 to point to the 2 on the right side. So we can set our root.left equal to our root.right. Set our root.right equal to our root.left. And so, let's see. So we flattened our left and right side. We kept track of our last element on our left side. We set our last element on left equals to root.right. So last element on left, or root.right equals left return, and then our root.right equals, I'm sorry, I just had a brain fart. Okay, so we flatten our right side, we flatten our left side, keeping track of this 5. We set, left return dot right. So this left return is the 5. The 5.right equals to our root.right. So our 5.right should equal root.right. And then we want to set our root.right to our root.left. So the 1, we want the 2 to be on the right side. We want this whole thing to be on the right side. So root.right is now equal to root.left, and then we can set our root.left equals to null. So that looks about good. We don't have a return value quite yet. but we'll see. We'll see if we need one, what it might be. So our second situation is if our root.left is null. And our root.right is not null. So if our left is null, then we just need to flatten our right. So flatten, return last, right. And we're going to have to return, but we'll save that for later. So else, if root.left is not null, and root.right is null. So if our right is null, we want to flatten our left side. So for example, this 4, our right is null, our left is not null, so we're going to want to flatten our left side and kind of change that to our right side. So we're going to want to move it to the right side. So flatten, return last, root dot. And we want to move it to our right side. And then we want to make our left side null, because we want everything on our right side. And then we're going to return something. So our last else is if both are null. So if both are null, we just have to return. So say we get to this 3, we'll just return it, even though it's not what we want, but it might be. So if we get to this 5, we'll just return it. So return root. So now for our return values. So when we call flatten from our first node, from our 1 on the left, we want to return the smallest element. So we want to, so we flatten, so we call flatten again. So it'll flatten this, then it'll flatten that, and if so it'll return this. So if our left is not null and our right is null. So for example, our left is null, but our right is not null. We're gonna want to return like the last element, the farthest down element to the right, always pretty much. So we'll return whatever flatten.right returns. So oops. So if our left is null and our right is not null, so we're just gonna return this. If our left is not null, but our right is null, so if we're here, then we'll just return whatever this returns. So we'll return flatten left. So create a tree node, return value, and then we'll return value. So if neither are null, or for example, say we have this 2, and we're flattening our left and we're flattening our right, we're having a 3 point to the 4, so we need to keep track of the last node in the 3. So we're going to want to keep track of the left. So we'll return whatever the left returned. Is that right? Hang on, sorry, brain fart. So we have this 2. We say we flatten this side, so now this is a 4 and a 5. Then we flatten this side. we say whatever this returned is, so we want to return whatever this returned, because when we are flattening this, we want to return what we need for the 1. So we're going to want to return our flatten right. So I have this right. So we'll create this return value. Okay, so I think that's right. Let me just look through it. So we can go through it once. I will delete this little arrow so we can kind of show like how I guess it progresses. So the first thing, so we get our root, so our 1. Root.left is not null, root.right is not null. So we'll say our return value is our whatever we get from the right. So it'll be whatever we get from this side. Our left return is whatever we get from the left side. Our left return, so hopefully our left return dot right. So this 5 will equal point to the 6. Then our root dot right will now be just the 2. And then our root dot left is null, and then we can return. So we don't really need the return, but for when we flatten the left side, so we'll need a return for here. So we flatten the left side, we say, okay, neither side is null, so our return value will be the flatten of these 2 nodes. Our left return will be the flatten return of root.left, so we'll flatten root.left, so then what we do, root.left, so they're both null, so we'll return this. So this 3 will be our left return. Then we say the 3.right equals root.right, so the 3's right is now the 4. The root.right is equal to the root.left, so the 2's right is now equal to the 3. The 3 is pointing to the 4. And then we're going to return whatever the flatten right returned. So the 2 is going to return to the 1 whatever this returns, whatever flattening this node returns. Sorry. So the 4, when we look at the 4, we're going to say, okay, the left is not null, but the right is null. So left is not null, but the right is null. So we're going to return whatever flattening the left returns. And then we're going to set our right equal to our left, and our left null, and then we're going to return it. So we're going to return whatever the flattening this returns. This will just return the 5. 5 will return this to the 4. The 4 will return this to the 2. The 2 returns it to the 1. And then the 1 does its magic. The 1 says, okay, 5, you now point to my right, which is 6. And I'm going to now point to 2. So we'll run this, see if we have any errors. We might. So we'll just run it. See what happens. Line 28, not a statement. Oops. Happens. So I think I see one error. I didn't return something if I have no return value. Well, I guess I do. One of these will always return, actually. So our expected answer looks correct. We'll submit it. And it's accepted. So we'll check our details. See how we did. All test cases passed, and our runtime beats 100% of Java submissions. So that's how you do it. I'll put a link to my GitHub where the code is in the description if you want to see that. I'll also put a link to the Leetcode problem. So thanks for watching. I hope you enjoyed. I'm sorry some parts were not very clear, but